Today's target will be literal equations. By the end of today's lesson, you will be able to recognize a literal equation. You'll be able to solve a literal equation for a given variable. Today's video should be relatively short as we're going to try to do some examples next time in class, but it's very important that you have an understanding of what a literal equation is and what it means to solve a literal equation for a given variable. So let's start by talking about what is a literal equation. It's an equation with multiple variables and or numbers. Okay, so the literal equation, you're going to have more than one variable. Okay, and then you also have some numbers mixed in. So with the equations we've seen previously only had one variable. You either solve for x or you solve for n, and you got that equal to a number. Here we've got multiple variables, so we're not going to be able to do that. What are some examples of literal equations? We've seen this one before, ax plus by equals c. That's a literal equation, has multiple variables. Okay. We can also put numbers in for a and b and c. So 6x minus 2y equals 12, for example. That's a literal equation. Another example of literal equations would be some of the areas and perimeter formulas that you probably saw back in pre-algebra and some of your middle school math. So for example, the area formula for a triangle, a equals 1/2 base times height. That's a literal equation. Or your area formula for a rectangle, area is length times width. That's another literal equation. Or maybe your perimeter for a rectangle, so 2 times the length plus the width. So all sorts of literal equations, but the general idea is that there's more than one variable. So let's look at how we actually solve them. Okay. So whenever you're given a literal equation, you're asked to solve it. You're going to be asked to solve for specific variables. So the first thing we're going to do is we're going to take this literal equation and we're going to solve it for y. Now, don't get overwhelmed by this because we've already done this. Okay. This is a standard form, and if we solve it for y, we're simply putting it into slope-intercept form. So it's the same steps here that we did previously. But we're going to look at it a little bit differently because we can't always apply the same two-step process. First thing we're going to do is we're going to say, okay, what variable are we trying to get? We're trying to get y. So we're going to underline or circle or put a box on, but something to indicate that's the variable you want to get. Okay? And then you're going to work backwards. What do I mean by that? I mean, take care of any addition or subtraction first. You're basically working in inverse order, the opposite order of your order of operations. Okay, so take care of any addition or subtraction first. So you notice that we've got this 3x over here that's being added. Okay, it's a positive 3x. So I'm going to go ahead and subtract 3x from both sides. Okay, cancels out here. Now one of the things you have to be very careful with literal equations is like terms. Okay, make sure you only add together terms that are like terms. So now what we have 4 on the left. 12 minus 3x is not 9x. We cannot combine those two, so we're going to just write them separately. The order doesn't really matter. You can put the 12 first, be 12 minus 3x, that's fine. Okay, but you cannot combine them. That's the important part. Now we're still trying to get this y by itself. We've got this 4 next to it. So we've got to ask ourselves, what's happening between the 4 and the y? Well, it's multiplying. It's 4 times y. Okay? Let me erase that and rewrite it so it's easier to see. This is really 4 times y. The multiplication is implied. So to get that y by itself, we have to do the inverse. The opposite of multiplication is division. So we're going to divide everything by 4. That leaves us, I'll leave that as a fraction, leaves us with this. So that's the equation solved for y. Okay. Now we can take that same equation and we can solve it for x. So I'm just going to rewrite it. We have 3x plus 4y equals 12. So up a little bit more space here. Now we're trying to solve it for x. So I'm going to look here and say, okay, I'm trying to get this x by itself. So now I've got to take care of the y. I got to get rid of this, move that to the other side because I'm trying to isolate the x. So it's plus 4y, so the opposite would be minus 4y. So I'm going to subtract 4y from both sides. Those cancel out. Leaves me with 3x on the left. Once again, the 4y and the 12 are not like terms, so I'm not going to combine them. Look over here and say, okay, what's going on between the 3 and the x? Well, it's multiplication. So I do the opposite, which is division. Which means I divide everything by 3. Those cancel out. And here I have the same equation. Now it's solved for x. Okay, so whenever you see solve it for x or solve it for y or solve it for a specific variable, it means you're trying to get that variable by itself. And once you have that variable isolated by itself, that's when you're finished. Let's look at a second example. Here's the area formula for the equation for area for a triangle. 1/2 base times height. So we're going to solve it for b, meaning we want to get b by itself. Okay? So if we look at what we've got going on here, there's no addition and subtraction. So we move on to the next step and look at multiplication and division. In between all of these are implied multiplication symbols. Okay? So we want to take this one step at a time. We're going to kind of just work left to right here. And start with this 1/2. Now what's the opposite of multiplying by 1/2? Well, the opposite of a fraction is its reciprocal. Okay? So the opposite of multiplying by 1/2 would be multiplying by 2/1. Okay? So we're going to multiply by 2/1 on both sides. 2/1 times 1/2 cancels out. And it leaves with b times h equals 2a over 1. Okay? Now I'm trying to get b by itself. So I've got b times h. So if I divide that by h, the opposite of multiplication is division. I also have to divide this by h. Okay, so I've already got a fraction, so when you divide, you're just putting it in the denominator. So I'm going to go ahead and put an h down here in the denominator. So that leaves me with b on the left side, and on the right side I have 2a divided by h. So I've got b by itself. So this is the area formula for a triangle solved for b. Alright, now it's your turn. Same equation, but I want you now to solve it for h. So use the example we just did. Okay, you've got 1/2 base times height equals a, and I want you to solve it for h. So take a second and do that now. Once you have it solved, press play and check your answer. Pause the video. If you're not done so already, pause it now. So here's your solution. Once again, we started from the left. We had nothing to add or subtract, just like the previous example. Opposite of multiply by 1/2 is 2/1, so we multiply both sides by 2/1, same as the previous example. Then the second step, right here, we're trying to get h by itself. So now rather than dividing by h, we're going to divide by b to get h by itself. So on the opposite side, we put b in the denominator, okay, which left us with 2a over b is equal to h. So that's what we have here. We'll do some more examples in class tomorrow, but make sure you bring your notes with you. So you've got a little bit of a base, a little bit of understanding. Also, as always, if you had any questions that came up during the video, make sure to make a note of them, write them down so that in class you can get them answered.